Hello, my name is Brian Wagner. In this video, I will explain what makes up ferro-paper and the basics of how it works. What you are seeing here is one of the two main parts that makes up ferro-paper. Looking at the picture, one may think that the paper has some quality that makes it more technologically advanced than others. Surprisingly enough, this paper is ordinary paper that can be found in a stack of newspaper or even inside an everyday printer. Paper is the foundation of ferro-paper. Without this paper, the technology would have no form. In order to create ferro-paper, the ordinary paper is impregnated with a magnetic liquid called ferrofluid. The impregnation is as simple as putting droplets of the liquid on the paper. The beauty of the paper used is that it acts like a sponge. Seeing as it is very porous and soft compared to other papers, it allows the paper to soak up a large amount of ferrofluid. When impregnated and there is an external magnetic field present, the paper is forced into movement. The movement of this ferropaper will be talked about later in the video. Here is a picture of ferropaper's other main part, ferrofluid. The ferrofluid is being forced to hold a shape by an external magnetic field. When an external magnetic field is not present, the ferrofluid loses its form and acts just as an ordinary liquid does. As one may have already been able to tell, the ferrofluid is the black figure on top, and the magnet placed under the ferrofluid brings on the external magnetic field. A thin glass plate is placed between the ferrofluid and magnet in order to keep the picture easier to understand. Ferrofluid consists of magnetic iron nanoparticles and everyday vegetable oil. Once the paper is saturated, as mentioned earlier, the ferropaper will react to a magnetic field. Because of the strength of the paper used, the ferrofluid is forced to keep in the same shape. This results in the ferropaper oscillating, which brings us to the next picture. Now that a good understanding of the main parts of ferropaper have been established, it is easier to comprehend the actual movement that ferropaper makes. Here is a visual of an experiment that shows the oscillation of ferropaper on a very simple scale. What is being looked at is a very small diamond-shaped piece of ferropaper that is mounted on top of a circular magnet. The ferropaper is placed at an equilibrium distance away from the magnet. This means that the magnet is both pushing and pulling on the ferropaper at equal magnitude. All that is needed now is to break the equilibrium state by merely touching the ferropaper, and a naturally forced oscillation results. A problem that arises with the ferrofluid impregnated paper that was not addressed earlier in the video is the paper's loss of stiffness when impregnated. The solution that has been found for this problem is by more or less dipping the resulting ferropaper into a biocompatible plastic liquid. When this liquid dries, it results in a film layer that makes the ferropaper stronger, stiffer, along with other positive results like resistance to water and a prevention of the ferrofluid from evaporating off the paper. As interesting as the technical use of ferropaper is, it also has an artistic value as well. A good example to relate this to is Newton's cradle. The metal balls found on some office desks, they use the conservation of energy principle in a very simplistic and appealing manner. After being impregnated and after given the biocompatible plastic film layer, ferropaper still has all the qualities of ordinary paper. This means that cutting and folding the paper can be applied in order to make the ferropaper itself act and react differently. A good example of the folded ferropaper is shown. Just because it is such a sophisticated technology does not mean that it cannot be applied for aesthetic purposes. Here is an origami crane that has been folded from ferropaper. When exposed to a magnetic field, the crane flaps its wings. This crane is just one of the many examples of ferropaper's artistic side. Once again, my name is Brian Wagner. I hope this has been an informative video. Thank you for your time.